Hello and welcome to Mr. Tompkins EdTech. This series of videos and their accompanying predicted papers are my best guess as to what you might expect in your next maths exam. This particular video covers AQA Paper 3. I've taken a look at what's already come up along with some statistical analysis of previous papers and drawn up a list of high frequency topics that have not yet been tested and are highly likely to appear in the coming paper. I've then selected some typical questions that you might expect to see on each of these topics and created a diagnostic paper for you to try. You'll find a link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on and, more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description, you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. Question 1, here is a rectangle. Work out the perimeter. Now, perimeter is if you imagine you're starting it in one corner of your shape and then you walk the entire distance around the edge, that is going to be your perimeter, isn't it? So in this case it's going to be 7 plus 5 plus 7 plus 5. So my perimeter is those all added together. 7 plus 5 plus 7 plus 5 is 24, isn't it? So it's that one there. Question 2, use your calculator to work out, and part A says root 196 plus 29. So I'm just going to type that in. There's the root key, 196. Now I need to press the right key to come out of that root, and then before I press the plus, otherwise it's going to continue under the root, which I don't want, and then I'm going to add 29 on the end. Okay, so make sure it looks like it's got on the page and that root sign doesn't go all the way over across to the 29, otherwise you're going to get the wrong answer. If you do it correctly, it comes out to be 43. Okay. Now, then I need to do 4 to the power of 5. So I'm going to press the 4 key first, and then I'm going to press this power key here, which is like an X with a little box. And in the box, I'm going to type in the power of 5, and that gives me 1024. 1024. Question 2a, reflect the triangle in the mirror line. Okay, so I think with reflection, the easiest thing to do is to reflect the points first. So take each point on your shape. Let's take this one here, and then see how far away it is from the mirror line. That's like 1 square to the mirror line. So its mirror image is going to be 1 square on the opposite side. It's going to be there. Similarly, this point here is 1 square away from the mirror line, so its image is going to be 1 the other side, like that. And then finally this one at the tip here. Now that's actually 1, 2, 3, 4 units away. So its mirror image point is going to be over there. Now once you've got your vertices or corners of the shape, you can then join them up with a ruler. Okay, so reflect the points, don't try to reflect the lines. It's normally when students try and reflect the lines, they go a bit wonky on these. Okay, just tidy that up a little bit, get rid of those, get rid of those. Okay, so there we go, that's my reflection. Oh, went a bit too far there, got rid of that point. Right, let's move on. Part B says rotate the triangle 90 degrees clockwise about the point P. Now with rotation, I do recommend that you use tracing paper. If they don't give you a sheet of tracing paper in the exam, you can just stick your hand up and ask one from the invigilators, they'll bring one over. Easiest way to do it really. So just put your trace of paper over the top of the shape, and then just mark the corners. I don't usually bother drawing the lines. You can join them up if you want. or just simply mark where the corners are. The other thing I like to do is I like to put a little cross on the point where we're rotating around, because that helps me work out when I've done 90 degrees. So when I turn this thing around, because I've got a cross on it, when the cross lines up again on your grid, then you know you've gone 90 degrees. Okay, then once you've done that, you can just kind of stick your pen underneath the tracing paper and mark out the points, and then you can remove your tracing paper entirely and then join up again. So again, we're rotating and we're finding the corners or the vertices. We're not trying to rotate the lines. Okay, once we know where the vertices are, we can just join them up afterwards. Okay, 90 degrees clockwise about the point P. Circle the unit of mass. Millimeters, that's a length. Grams, that is a mass, isn't it? Liters is a volume. And degrees is an angle, so it's going to be grams. Simplify 3a plus 7b minus a plus 4b. Okay, so we need to collect like terms. So we've got terms in a, 3a minus a, and we've got terms in b, plus 7b and plus 4b. Now notice when I highlight those I highlight the sign that goes in front of them, because that is part of what we're doing, isn't it? So 3a subtract a is 2a, and 7b plus 4b is 11b. So we get 2a plus 11b. 8b, expand 4 lots of 2d plus 5. So single brackets, a number on the outside, that gets multiplied by everything inside the bracket. So 4 times 2d is 8d, and 4 times 5 is 20. There's a plus sign in the middle, so it must be plus 8d plus 20. Finally, we're asked to factorize 15x plus 18y. Now that's pretty much the opposite of what we were just doing. Expanding removes brackets, and factorizing puts them back in. The thing that goes on the outside of the bracket is the thing that's common to both terms. So we've got an x in one and a y in the other, so they're not common, but we've got a 15 and an 18. 15 and 18 are both in the 3 times table, so I can put a 3 on the outside. Now to work out what goes on the inside of the bracket, we just need to think about, well, what 3 times what is going to give me 15x? Well, 3 times 5x gives me 15x. We're going to have a plus in between. And 3 times what gives me 18y? Well, 3 times 6y must give me 18y. So I get 3 lots of 5x plus 6y. Jack and Liam each get the same pocket money. Jack spends 75% of his and has £2 left. Liam spends 40% of his. How much does Liam have left? Well, if Jack spends 75% of his and he gets and he's got £2 left, then 25% is what he has left, isn't it? And that is equal to £2. So if 25% is equal to £2, then 100% is going to be 4 lots of that, isn't it? Okay, and 4 lots of £2 is £8. So that means that Jack must have had £8 pocket money to start with. Now we know that Liam has the same amount of pocket money, so he must also have £8. So if he spends 40%, then he's got 60% of his pocket money left. So what we need to do is to find what 60% of 8 is. So using our triangle, final, original, multiplier. Our final is what we're trying to find. Our original is £8, and our multiplier, let's say we want to find 60%, don't we? 60% of the amount, which has a multiplier is 0.6. So to find our final, just cover that up is original times multiplier. Final is equal to original times multiplier. So 8 times 0.6, which is, according to my calculator, 8 times 0.6 is 4.8. Now remember, this is money though, so we're going to have to write that as pounds and pence. So he's got £4.80 left. Now you could have also found out what 40% was and deduct it from the £8 to get the same answer if you wanted to, but this way is quicker if you know what you're doing. Question 5, Lev, Maria and Nicholas, which we're going to denote with L, M and N, sit in a row of 3 seats. Use the table to list all the different orders in which they could sit. One possible order is already shown in the table. You may not need to use all the rows of the table. Okay, so we've got seat 1, 2 and 3, and the first arrangement is L, then M, then N. And we need to find all the other possible arrangements. Now when you're listing things, my recommendation is to try and keep the first thing the same first. So for my next arrangement, I'm going to keep L the same at the front here, and then I'm going to switch these other two around. So these two are going to switch over and become N and M, like that. Now, are there any more arrangements with L at the front? Nope, that's all of them. I can have L, M and N, or L, N and M. So now that I'm done with L, I'm going to switch around and I'm going to start looking at M at the front. So I'm going to bring M to the front and draw it here. And then I'm going to do the same thing. I'm going to then do L and N here. Okay. I don't know why I'm color coding them. I just kind of got into the thing of it now, and I feel like I should continue. So then I'm going to keep M the same at the front, and then I'm going to switch those two around, N and L. Why did I start this? Okay. I just feel compelled to continue. And then so I've done all my M's, and now I'm going to bring N to the front, and I'm going to do L and M, and then N, M, L, and weirdly I'm just going to finish colouring them in because I don't know. There we go. So yeah, we've got 2, 4, 6 of those all together. All possible orders in which they could sit are equally likely. What is the probability that Lev sits next to Maria? So probability of L next to M. Now that's equal to successful outcomes divided by total outcomes. Okay, now the total outcomes are the fact that I've got 6 different arrangements. I've just worked them out in part 1. I worked out 6 different ways of arranging those 3 people next to each other. So that's the number on the bottom. Now the number on the top is going to be the ones that meet the criteria. How many of those outcomes do have Lev next to Maria? Okay, well, I can see Lev is next to Maria in the first one there. They've got Nicholas in between them for the second set, so that doesn't work. I've got Maria, Lev there, so they are next to each other. And then Nicholas sneaked into the middle again there in the third one and the fourth one. And then I've got them together over here, and they're together over here. Okay, so they're actually sitting together in 4 out of those 6 arrangements. It's only when Nicholas sneaked between them in the second and the fourth one that they were parted momentarily. So anyway, so it's going to be 4 out of 6. Now you might feel the urge to cancel that down, but actually you never get any extra credit for cancelling down fractions in papers. So yeah, you can do it. You can if you want. It's not necessary. So 2/3 is the most simple version of it, but it doesn't tell me to specifically simplify, so you're not going to get any credit for doing that. Here are the first 3 terms of a sequence, 23, minus 14 and 9. Now we're told that each term is obtained by adding the previous 2 terms together. So that's a bit like the Fibonacci sequence. Now normally with the Fibonacci sequence we start with 1 and 1. Here we've got 2 different starting points, but we're following the same rules. that we take this one and this one, we add it together, and it gives us the next one along. Okay, so what is the next term in this sequence? Well, the next term I'm going to get by taking my minus 14 and adding on the 9. That's going to give me the next number in the sequence. So negative 14 plus 9 is minus 5. So my next term in the sequence is negative 5. And then my next term I'm going to get by adding 9 and negative 5 together. So 9 plus negative 5 is 4. So I'm going to get negative 5 and 4. Right, now part B says the sequence continues. How many negative terms are there in the sequence? Okay, well, we've had 2 so far. We've had minus 14 and minus 5. Now what's going to happen next? What's going to happen as our sequence continues? I think we're going to need a few more terms, aren't we, to work this out. So we know that there are, well, we've already got 2, so, but will there be 3, 4 or more as the sequence continues? So let's just write down the sequence again. 23 minus 49 minus 5, 4. Oops. So we've got 23 minus 14, 9 minus 5, 4. Is that right? Yeah, so what's the next term in the sequence? The next term is I'm going to get by adding minus 5 and 4 together. So negative 5 plus 4 is minus 1. So there's at least 3. And now my next term after that, I'm going to get by adding 4 and minus 1 together. 4 plus minus 1 is 3. And then my next term, I'm going to get by adding minus 1 and 3 together. So after that, I'm going to get 2. And my next term after that is adding 3 and 2 together, which is 5. Now, notice now that everything is positive. From this point on, I'm just going to get more and more positive numbers, aren't I? Because 2 plus 5 is 7, 5 plus 7 is 12. After that, my whole sequence is going to be positive forevermore. So how many negative numbers were there? I had my minus 14, my minus 5, and my minus 1. And after that, everything is positive. So 3. Use your calculator to work out 9.95 squared times 29.8. Okay, so we've managed to gain quite a few marks already in this paper just by being able to type nicely into my calculator. So 9.95 squared times 29.8 equals, write down your full calculator display. So 2950 .2745. Okay, that's what I got. Right, question 14b. Is your answer to part A sensible? Use approximations to decide. You must show your working. Okay. So what asking me to approximate that answer now and compare it with my answer to make sure that I did it correctly. Okay, so let's do that then. So if I look at 9.95, I'm going to round each one of these numbers off to one significant figure. So the first significant figure in 9.95 is the 9, which is in the units column. So 9.95 to the nearest unit rounds up to 10. So I'm going to get 10 squared times 29.8. So the first significant figure of this number is the 2, which is in the tens column. So let's round 29.8 off to the nearest 10, which is 29.8 is nearest to 30, isn't it? It's nearer 30 than 20. So it's going to be 10 squared times 30. Okay, so let's work out down here 10 squared times 30. Well, that's just 100 times, not 106, 100 times 30, which is 30 with 2 extra zeros, 3,000. Okay, so my estimate was 3,000. My actual answer was 2,950. So that's not bad, is it? It's only 50 out, which is not too much when you're talking about thousands. So yeah, I'm going to say it was sensible. In a game, Anna has to describe a hexagonal prism. She must not use the word hexagonal or prism. She says it has a uniform cross-section, it has 6 faces, it has 12 vertices, it has 12 edges. Correct any mistakes that Anna has made. Okay, so it has a uniform cross-section. That is true. A hexagonal prism is a hexagon all the way through, isn't it? So it's like a shape that looks like this. Okay, so it's going to have a uniform cross-section. So that is correct. It has 6 faces. Does it? I'm not sure that is true. It's going to have one face for every side here of the hexagon, isn't it? So that's 1, 2. It's going to have another one there, 3. Then it's going to have 4, 5, 6. But then it's going to have the front face, which is 7, and then the back face, which is 8. So altogether it has 8 faces. Okay, does it have 12 vertices? You've got 1, 2, 3, 4, 5, 6 vertices. Vertices are the corners of the shape. So you've got 6 on that face, and you can have 6 again on the back. 2 I can't see, so that is correct. 6 and 6 makes 12. Does it have 12 edges? Well, it's got 1, 2, 3, 4, 5, 6 along there. It's going to have 6 there as well. 3, 4, 5, 6. That's 12. Plus, it's going to have 1, 2, 3, 4, 5, 6 going that way. So that isn't true. It's going to have 18 edges. So correct any mistakes she has made. She needs to say it has a uniform cross-section. That was correct. It has 8 faces. It has 12 vertices. And it has 18 edges. Question 16. Which shape must have rotational symmetry? Circle your answer. Now what this question is missing is diagrams. You haven't got any pictures of any of these things. So let's quickly sketch these in. So that's an isosceles triangle, isn't it? A trapezium. What does a trapezium look like? Okay, that would do. So there's my trapezium. A kite. I have to draw this one with a ruler because it wouldn't let me draw it with the auto shape. It kept drawing a rhombus and not a kite. So let's draw it properly with a ruler. And then the parallelogram. I've got a shape for one of those. Okay, so if they haven't got these diagrams in your exam paper, then just draw them in. Okay, so then you can have a look at them. You can imagine them then. So which shape must have rotational symmetry? Now the isosceles triangle is not going to lay on top of itself when you rotate it. When you're looking at rotational symmetry, you've got to imagine that you can put a pin in your diagram and spin it around. And which ones are going to look the same in as you turn it 360 degrees around. Now the isosceles triangle is going to have rotational symmetry of order 1 because it isn't going to look the same until it gets all the way back to where it started from. Same with the trapezium, same with the kite. Parallelogram though is going to have rotational symmetry of order 2. It's going to look the same upside down as it is the right way up. Okay, so which one must have rotational symmetry? It must be the parallelogram. During year 10, a school trip runs to Austria and a trip to France. So we're told that 63 students go to Austria, 89 students go to France, 15 students go to both Austria and France, and 50 students do not go on either trip. how many students are there in year 10, and you can use a Venn diagram to help you. Okay, so we've got a Venn diagram here with two circles. So I'm going to label one A for Austria, and I'm going to label one F for France. Now, it's not so handy to put these first two in. 63 students go to Austria because I might have some here and some here. So it's not so handy to start with those. What it's good to start with is the number that go to both. So if you have a look at this one here, 15 students go to both Austria and France. Let's start with that one. So the number of students who go to both is the one sitting in the middle. So we know there has to be 15 that go to Austria and France. Now we know how many are in the intersection there. We can then go back and look at the other facts. So 63 students go to Austria. So if 63 people altogether inside that A set, and I know that 15 are going to both, then 63 subtract 15 must just be going to Austria by itself. And 63 take away 15, 63, 53, 48. I'm going to have 48 students going just to Austria only. So then my 48 and 15 add up to 63. What other facts have I got? I've got 89 students go to France. Again, similar logic. If I know that there are 89 students altogether in the F circle and 15 already in the middle, then 89 subtract 15, 89, 79, 74 students. Again, I've got my pen the wrong way around. 74 students go to France only. And I've got 54 students do not go on either trip. They're the people who lie outside the two circles. Got 54 didn't go to either. So now I can work out how many students there are altogether. So the total number of students is going to be those four numbers added up, isn't it? It's going to be 48 plus 15 plus 74 plus 54. So reaching for the calculator. 48 plus 15 plus 74 plus 54 gives me a total of 191 students. Okay, so that's my answer, 191. The pie chart shows some information about the share of votes for candidates in an election. And we're told that it's not drawn accurately. Okay. Now it says the angle for Mrs. Wood would be 24 more than the angle for Mrs. Patel. There are 5,220 votes in total. Work out the number of votes for Mrs. Patel. Okay, so we don't know what Mrs. Wood got, but we know that it's 24 more than Mrs. Patel, but we don't know what Mrs. Patel had. So let's say that Mrs. Patel has X votes. Then Mrs. Wood is going to have 24 more than that, so she's going to get X plus 24. Okay, and so all of those added together is going to give me 360 degrees, which is the total number of angles in a circle. So I can write that down then. So my 64 plus my X plus my X plus 24 must be equal to 360 degrees. Okay, so then collecting like terms, I've got a number 64 and 24, and I've got an X and an X. So adding like with like, so 64 and 24 gives me 88 plus 2x is equal to 360 degrees. Okay, so subtracting 88 from both sides, that's going to leave me with 2x is equal to 360 subtract 88. Just going to do that on my calculator. No point in risking making an error. So that's 272. And then to find x, I'm going to have to divide by 2 then, aren't I? Divide by 2, divide by 2. So then x is going to be 272 divided by 2, 136. That means that angle there is 136 degrees, and then Mrs. Woods is going to be 24 more than that then. That's going to be 136, 140, 160 then, isn't it? Hers is 160 degrees. What do we need to do now? We need to work out the number of votes for Mrs. Patel. Okay, so we know that Mrs. Patel's angle is 136. So her fraction of the vote is going to be 136 out of 360 times the total number of votes. So you can use 136, 360, it's like a fraction. So we work out that fraction of the total. So what is 136 360ths of 5,220? Okay, we can just tap that into the calculator using the fraction key. So using the fraction key, 136 over 360 multiplied by 5220 gives me a total of 1,972. Okay, so Mrs. Patel must have got 1,972 votes. A shop sells raincoats and umbrellas, and the scatter graph shows the monthly sales from 12 months. So you can see throughout the year that the sales are generally going up. So you can see from the graph, you've got vaguely strong positive correlation between the sale of raincoats and the sale of umbrellas, which is not that surprising because I'm assuming that raincoats and umbrellas are bought most when it rains a lot. And you tend to buy them together. So write down the type of correlation shown by the graph. This is what we call strong positive, because there's a clear upward line of best fit going through those. The manager expects sales of umbrellas next month to be £60. Draw a line of best fit to estimate the sales of raincoats next month. So I'm going to draw on our line of best fit. Probably should have done that to answer the first question. Right, I'm going to draw my line of best fit about there, I think. Maybe a bit more higher. It's a little bit subjective. You'll get a fair bit of leeway about where your line should go. Should have roughly the same amount of points on either side. I think I've got like 5 on each side, and it kind of vaguely follows the line of travel up the graph. I'm reasonably happy with that. You will get a fair bit of leeway when you draw your line in. So that's my line of best fit. Then I'm going to estimate the sales of raincoats next month when the sale of umbrellas is going to be 60. So I'm going to look up from 60 umbrellas, or £60 worth of umbrellas. Read up to my graph. And then change direction. And read across to my raincoat line. It's about there, isn't it? Okay. So you can see my line ends up about there, just over 125. Now each one of these little boxes, there are 5 little boxes and they span a different distance of 25, so each one must be 5. I've kind of drawn mine between 2 boxes, so I'm going to estimate that to be about 127, something like that. Okay, so draw a line of best fit to estimate the sales of raincoats. I think it's going to be 127. Now, like I say, there's a fair bit of give in this question, so don't worry if yours isn't exactly the same as mine. Question 19, a equals 7, b is equal to 2. Work out the value of a over b minus a to the power of b. Okay, so we've got some substitution to do here. So a over b is 7 over 2 minus a to the power of b, 7 to the power of 2. Okay, so I've got 7 divided by 2, subtract 7 squared. So again, let's just think about BIDMAS and make sure we do this in the right order. We've got no brackets, but we do have some indices this time. So the first thing we're going to have to work out is this one, 7 squared. Okay, so that's going to become 7 over 2 subtract 7 to the power of 2. 7 to the power of 2 is 7 squared. 7 times 7 is 49. So I'm going to have 7 over 2 subtract 49. Okay, my division comes next. What is 7 divided by 2? Half of 7 is just 3.5 or 3.5. So I've got 3.5 subtract 9, and then finally, so I did the indices first, then I did the division, and now I'm going to do the subtraction. That's the last thing to do. So 3.5 take away 49. Well, 49 take away 3.5 would be 45.5. So 3.5 take away 49 is going to be minus 45.5. Okay, and that's going to be my final answer then. So 3x minus 8 is equal to 19. Okay, so I've got 3x minus 8 is equal to 19. Now if I want to solve it, that means to find the value of x. So we need to get x by itself. Okay, now I can do that firstly by adding 8 to both sides. That's going to get rid of that 8 on that side, because negative 8 plus 8 is 0. So that is going to give me 3x is equal to 19 plus 8, which is 27. And the next thing I can do to try and get x by itself is to try and divide both sides by 3. Then 3 divided by 3 is just going to leave me with the x, and 27 divided by 3 is 9. So that tells me that x is equal to 9. That's my final answer, 9. That gives us a distance time graph showing the journey of a toy train. And underneath we have 4 possible descriptions of the first 2 parts of the journey. Now let's have a look at the first 2 parts of the journey. This first part here is a straight line, and it is increasing as time increases, so it's sloping upwards. So that indicates that the toy is moving at a constant speed. And then the next part, the distance isn't changing for a period of time, so that would indicate that the toy train is at rest. So which one of the descriptions most accurately displays that? So it must be B, moves at a constant speed and then is stationary. Okay, for part B, it says work out the average speed for the last 4 seconds of the journey. So average speed, if you remember your DST triangle, average speed is equal to distance traveled divided by time taken. And from our diagram, the last 4 seconds is this part of the graph. Well, we know the time. The time is the 4 seconds. So this is how much time it takes, 4 seconds. And the distance traveled then is going to be the distance from 4 to 10, which is a distance of 6 meters. So it's gone 6 meters in 4 seconds. So then average speed then is going to be our 6 divided by 4, which is 3 over 2 meters per second. Question 7, vectors A and 4B are drawn on the grid. And then part A says, write vector A as a column vector. Okay, so column vectors are written in the form x over y, where x is the distance from one end of the vector to the other in the direction of x. So you can see that's 4 units in that direction. And then in the direction of y, which is, it's actually, y is how many units up it is, and this is actually 2 units down, so this is considered to be minus 2. So the column vector is going to be 4 units in the direction of x and negative 2 units in the direction of y. And then part B says, find the vector B as a column vector. Okay, now we've actually got 4B here. It doesn't actually fit nicely on the grid. I'm just gonna work out what 4B is first, and then I'm going to divide it by 4, I think. So 4B, that is equal to, I'm going to do the same thing. How many units in the direction of x, and how many units in the direction of y do we need to go? Well, this is 1, 2, 3, 4 units in this direction, and 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. You see, they're being a bit cruel to us here. So that's going to be 4, 9 then. So the vector b by itself is going to be a quarter of that then. So it's going to be a quarter of 4, 9, which a quarter of 4 is just 1, isn't it? So the top number is 1. Now the bottom number is going to be 9 divided by 4, which is, I'm just going to write it as 9/4 actually. So it's 9/4. 1 and 9/4. Question 22a, complete the table for y equals x squared minus x. Okay, now with these tables that you need to complete, the easiest way is to use the table mode on your calculator if you've got a Casio. If you don't have a Casio, you really want to get one of these because they've got lots of features that are very handy for your exam that you miss out on otherwise. So if you tap on mode and go to table, then you get f of x is equal to displayed on your screen. So it uses a slightly different notation. F of x is the same thing as y basically. So y is equal to, and then we just type in the bit on the other side of the equal sign, x squared minus x. Now to type in the x, you need to press the alpha key, and then the x here is above the bracket. So x squared minus, and then alpha x again. Okay, so x squared minus x. Press enter. You're going to get g of x appear. Now we've only got one function to type in this time, so we can leave that one blank for now, and then press enter again. Then the start value is going to be, well, I would go for either look at the table. If it gives you an x value, fine. If it doesn't, then what you can do is just look at the x-axis on your diagram and then pick out the number on the far left and the far right as your start and end values. So I'm going to be starting at -2, I'm going to be ending at 3. Now the step is what we're going up in this case. You can see here we're going up in ones, so we're going to go up in ones, and then press enter. You can see I'm going to get a nice table displayed with all the values in that I need. Okay, so on my table then, the first box is -2 goes with 6, so I'm going to put in my -2 in there, and then I've got -1 goes with 2, so -1 goes with 2, 0 goes with 0, which matches, 1 goes with 0, 0, 2 goes with 2, and 3 goes with 6, so the rest all matches. Okay. So we filled out the table, and that was really easy. Just make sure you use the table because it does make life a whole lot easier. Part B, the graph of y equals x plus 1 is shown on the grid. It's already drawn. On the same grid, use part A to draw the graph of y is equal to x squared minus x for the values of x from -2 to 3. So basically we just need to plot those points, and don't we? Okay, so -2 goes with 6. -2 goes with 6, so that's a point there. -1 goes with 2. 0 goes with 0. 1 goes with 1. 2 goes with 2. And 3 goes with 6. Okay. Now this is a quadratic curve. It has a nice smooth parabola between the points. So that's what you're going to be drawing on this shape. Okay, so it's a curving thing. Should be symmetrical on both sides. Now it doesn't have a flat bottom, so it will dip below the axes between 0 and 1 and then start coming back up again. Okay. Now try and do a smooth line. It doesn't matter if it's a little bit wobbly, okay, but what you shouldn't have is feathering, so not multiple lines, and you need to try and skewer each of your points. So do try and go through each of the points you plotted. Okay, so a little bit of wiggle is not important, but you know, nailing the points and not doing multiple lines between points is that's what you're going to actually lose mark for. Now the last point says write down the x coordinates of the point where the two graphs cross. Now you can see they cross in two places. They cross here, look, and here. Now we want the x value, so if I just get a ruler and I read down to the axes, it's probably the easiest thing. Over here. Okay, so the first one looks slightly to the right of like a -1/2, but only ever slightly, and so I'm just going to leave it as -0.5, and then the other one is slightly to the left of 2.5, but not enough for me to change the value again, so I'm just going to put in -0.5 and 2.5. So -0.5 and 2.5. Okay, and I think we're done. Question 7. Sam types a constant number of words per minute. He takes 8 minutes to type a report of 416 words. How long does it take him to type an essay of 1,534 words? Give your answer in minutes and seconds. Okay. So I think what I'm going to do is just going to convert minutes into seconds to start with, because otherwise it's going to be difficult to calculate with. So 8 minutes, I can just type that into my calculator actually. So 8 times 60, that's 480 seconds, isn't it? So I can write that as a ratio, can't I? So if I do time to words as a ratio, so I know then it took him 480 seconds to produce 416 words. Okay, now I want to know how long it's going to take him to produce 1,534 words. So I can use something called the unitary method and go via 1, okay, by dividing by 416 and then multiplying by 1,534. If I do the same thing this side, so 480 divided by 416, okay, that comes out to be, well, 15 over 13. I might just write it down as 15 over 13 because it'd be quicker. So 15 over 13, and then multiply that by 1,534. I get 1,770. Okay, so that means it takes 1,770 seconds in order to type that amount of words. Now, what's that in minutes and seconds? So to convert that into minutes and seconds, I'm going to divide it by 60. Okay, now that's probably going to give me a horrible answer. Oh no, not that horrible. But then if I then press the hours, minutes and seconds button over here, you can see it's going to convert it into 2930, which is 29. So that's going to give me 29 minutes and 30 seconds then as my answer. The angles in triangle A are in the ratio of 1 to 2 to 3. The angles in triangle B are in the ratio of 4 to 5 to 6. Now Jack says the middle number in each ratio is 1/3 of the total. So one of the angles in each triangle is 60 degrees. Is he correct? Okay, there's probably 101 ways of doing this, but I think what I'm going to do is work out what the middle angle is for each of these. That seems to be the easiest and straightforward way of doing it. So let's start with triangle A, which is in a ratio of 1 to 2 to 3. So in triangle A, our ratio of 1 to 2 to 3 gives us 1 plus 2 plus 3 parts, which is 6 parts. And we've got 180 degrees to share out, so 180 divided by 6, and then times by 2 is going to be our middle angle, which is 60 degrees. In triangle B, our ratio is 4 to 5 to 6, which, if I add those up, 4 plus 5 plus 6 is equal to 15 parts. And then 180, which is the angles in a triangle, divide by our 15 parts and times by 5, again is 60 degrees. So it looks like Jack is correct. So Jack is correct.
That's all. 3 straight lines are shown. Work out the value of x. Okay, well, they aren't just any old 3 straight lines, are they? We've got 2 lines here that have got arrows on them, which means that these are parallel lines, and we've got a line crossing them. And whenever we've got that situation going on, it forms various angles, and there are relationships between various angles that are formed. Firstly, if you have a think about that angle there, it is vertically opposite this one, which means that those two are equal. So that one must also be 2x plus 15. And similarly, this angle and this, so that one and that one are equal, but also that one and that one must be equal because they are what we call corresponding angles. So in other words, 2x plus 15, that angle up there must be the same angle as 3x minus 38. Now they might look different because they're written algebraically using different expressions. But if they're the same angle, then these two algebraic expressions must actually be equal. So if we equate them like that, we form an equation in x that we can then go on to solve. Firstly, we've got x's on both sides. So let's simplify it a little bit by subtracting 2x from both sides. So if I take 2x from that side, they'll disappear. If I take 2x from the other side, it's going to leave me with 15 is equal to x minus 38. Okay. Now, all I need to do is add 38 to both sides. You'll see that minus 38 plus 38 are going to cancel each other out, leaving you with x on the right. And on the left, 15 plus 38, that's 38, 48, 53, isn't it? That tells me that x is equal to 53. A chariot collection is made. Information about the amounts given by men is shown in the table. The mean amount given by women was £6.30 per person. Compare the mean amounts given by men and women. Okay, we have a grouped frequency table here, so we can't find an exact mean. What we can do though is estimate it using the midpoints of each of the ranges we've been given and use that as an estimate. So 0 to 5, to find the midpoint of those two, you can add them together and divide by 2. So not plus 5 is 5, divided by 2 is 2.5. 5 plus 10 is 15, divided by 2 is 7.5, and 10 plus 15 is 25, divided by 2 is 12.5. Okay, so they're my midpoints. So then we need to multiply those by the frequency and then add them up. So 2.5 times 11 is 27.5. 7.5 times 7, 52.5. And 12.5 times 2 is 25. So adding all those up, so 27.5 plus, 27.5 plus 52.5 plus 25 gives me a total of 105. So then the men's mean is going to be my total, which is 105, divided by the number of people, which is 20. So 105 divided by 20 is £5.25. So it looks like the chaps were the cheapskates and gave £5.25 on average. Now, we have found the mean, but we haven't compared the mean yet. So to compare it, we need to say which one is bigger. So women gave more money on average. So that's our comparison. The diagram shows a cuboid and its diagonal, and the formula to work out the length of the diagonal in centimeters is length of diagonal equals the root of a squared plus b squared plus c squared. This is one of those interesting extensions of Pythagoras theorem. So when you move from 2 to 3 dimensions, all you got to do is add in your extra length to work out the length of the diagonal. Quite cool. So what do we have to do here? Work out the length of the diagonal where A is 8, B is 3, and C is 2. We just need to put those numbers then into the calculation and work it out. So length is equal to the root of A squared, 8 squared, plus B squared, 3 squared, plus C squared, 2 squared. So job for my calculator, root 8 squared plus 3 squared plus 2 squared. That gives me 8.77. Oh, two significant figures, 8.8. Okay, now part B then says work out the length of the diagonal in terms of A when B is 2A and C is 2A. Okay, so we've got to do the same thing algebraically now. So the length is going to be equal to the root of A squared plus B is going to be 2A, so 2A squared, and C is going to be 2A squared, like that. So how many A squares have we got then? I've got A squared plus 4A squared plus 4A squared, which gives me 9A squared, and the square root of 9A squared, well, the square root of 9 is 3, and the square root of A squared is A. So it gives me 3A. And obviously when you square root, you often get two results, positive and negative, but in this case, there is only one solution that's valid, isn't it? It's 3A. Eva writes 4 squared times 4 squared times 4 squared equals 4 to the power of 2 times 2 times 2, which is 4 to the 8. What is wrong with her method? Eva. I hope you haven't got your exam in a few weeks' time. Now, obviously, when you've got numbers with the same base and you multiply them together, you add the indices, you don't multiply them. So give the correct answer. Well, it should be 4 squared times 4 squared times 4 squared is equal to 4 to the power of 2 plus 2 plus 2, which is 4 to the power of 6. In the diagram, DC is parallel to AB. So DC is this line here, AB is this line here, and you can see that they are parallel. Okay, so I've got a pair of parallel lines. It's not a parallelogram. Looks a bit like one, but those other two lines are not parallel. Now it asks me here to show that the triangle ABD is isosceles. So where's ABD? ABD is ABD, this triangle here. That's the triangle I'm looking for. And I need to show that it's isosceles. In other words, I need to either show that the lengths of two sides are equal. I'm not going to be able to do that. Or I can show that this angle and this angle here must be equal to each other. Okay, so I know the angle at the top is 124, so I need to show that this angle here then and this angle here are going to be isosceles. Are going to be equal to each other and therefore isosceles. Okay, so how am I going to do that? Well, let's have a look at the other triangle first, the triangle BCD, which is, I'm making a bit of a mess of this diagram. It's this triangle over here, look. Okay, so the blue triangle, I know 2 out of 3 of the angles from the blue one. I've got 152. So the angle at the top there, this angle up here, is going to be, well, the angles in the triangle add up to 180 degrees, don't they? So my 100 plus my 52 plus my angle there equals that angle there, doesn't it? So I know that that angle is equal to 180 minus the other 2. So it's going to be 100 plus 52. 100 plus 52 is 152. So 180 minus 152, what's that equal to? So 180 minus 52 is 180 minus 150 is 30, and 30 subtract 2 is 28. So that angle there is 28 degrees. Okay, so I know that one's 28. How's that helping me? Well, when you've got a pair of parallel lines and a line crossing them, then the angle there and the angle there we call alternate, don't we? And we know that alternate angles are equal. So that angle is going to be the same as that one down there. So on this diagram, that 28 is going to be the same as this angle down here then, isn't it? That one there is 28 because they're alternate. So I now know that that angle there must be 100, that is 28. So then this angle up here then, again, is going to be 180 subtract the other two. So 180 subtract 124 plus 28. So 124 plus 28 is what? 124, 144, 152, isn't it? 180 minus 152. Oh, look, that's equal to 28 as well. That's also equal to 28. Okay, so we've shown then that both angles are 28 and therefore is isosceles. So we can say that angle ADB is equal to angle ABD, and that's equal to 28 degrees. So triangle is isosceles. Okay, done.
Mr. T, he's the best, helps you